Tonight on Light Talks, we talk to Lisa Burrows, Laser and Alignment Systems Engineering Work Center Supervisor from the home of the world's largest, highest energy laser, the National Ignition Facility in Livermore, California. Welcome, Lisa. Hi, I'm Maya Romy, and this is Kirsten Lynn. You're ready to get started?
Okay.
All right. So Lisa, tell us a little bit about yourself. Where did you go to school?
So way back in the 80s, I went to school at it was a two-year vocational school in Wausau, Wisconsin. So it was called North Central Technical Institute. Currently now it's North Central Technical College. I was in the laser program that was called Laser Technician. It was an AS degree, two-year degree. However, that program, I believe in the 90s, kind of, I don't want to say fell apart, but just stopped being in existence. So that's where I went to school. Like I said, it was a two-year degree. It took me 3 years to get through because I had to wait for a class to become available. It was same probably for, you know, all of you going to school. Sometimes you just have to wait on a course.
Yeah. So what made you pursue a career in the field of photonics?
Yeah, so when I was in high school, I think junior, maybe early senior year, the vocational school had what they called mini courses. And so every Tuesday or Wednesday night, they would have 2 or 3 hours, or I think it was a 4-hour class of different courses to have you become familiar with what you did. So one was data processing, and then the other class was the laser technician. And they had a number of other different mini courses, but I had no desire to be an accountant. I had no desire to be administrative, that sort of thing. So I took the data processing and realized I don't want to do that because it was strictly back in the early 80s, sitting at a computer, you know, the 10-pin keypad, inputting data 8 hours a day, every day at a desk. And that was not something that I, at that time, envisioned to do for a career. And then I just took the laser technician class and enjoyed it because I was always good at math, or I felt I was good at math and science. And it just had a lot of interesting things, you know, as Kirsten, as you know, and Drea, you probably too, you know, there's electronics, there's mechanical, there's photonics, there's optics, there's physics. I mean, there's all of these different branches of information that you use and that you kind of have to know. For me, I believe, you know, a little bit of everything, right? You know, we're not physicists, so we're not an expert in physics. However, you know, we need to know about physics. And so we're kind of this, you know, jack of all trades. And so that's what interested me in taking the laser class, or the laser technician course.
Thank you for sharing. So progressing forward now, in your current position, what are your day-to-day responsibilities?
Yeah, so currently I am a manager, and so it is strictly administrative. I used to be a technician, you know, in my past working life, but now what I do is I schedule all maintenance, I schedule troubleshooting, I schedule repair for all of NIF's 192 laser beams. So that can go anywhere from, you know, having the technicians go out in the field and look at a motor and say, oh, well, the motor works, but the driver doesn't. So then if the driver's not working, then, you know, the technicians will then call the hardware technicians to come in and fix that driver. I mean, there's, you know, all of these different protocols, but it's anywhere from doing that to scheduling the major what we call FM&R, facility maintenance and reconfiguration, where we shut the facility down for 2-3 weeks, and we will remove a large portion of the beam path and do work on it. And so I will schedule one, how to turn everything off before they get into the beam path and work on the beams. And then once they're done with that work, how do we then make that system operational again and qualify it to where shot operations or NIF can shoot that laser beam. So it runs a gamut from something very small that'll take 15 minutes to, you know, scheduling a 2-week path of, you know, commissioning and reconfiguration. So
Yeah.
NIF itself is 192 laser beams. It's probably, I think the number is like 80,000 control points, which means there's motors and cameras and wavefront sensors, and I'm going to forget a lot of these different points. But, you know, as Kirsten knows, and she works in the facility, at any shot on any given day, in any given moment, something can fail. And typically something always does. However, there's a lot of workarounds that experts like Kirsten and, you know, the other technicians we have in our group are able to, you know, get us through the shot and figure out.
Thank you.
Sure.
So how long have you been here at the lab?
So it's kind of a complicated story. I started in 1985 and I worked in the AVLAS program, which was atomic vapor laser isotope separation. And that was at the time the largest, it was the highest, highest average power laser in the world. And so that was from 85 to 99. I was laid off because the program was no longer funded. Then I got a part-time job, but I stopped working at the lab, raised my kids. It was from 1999 to 2008. And then in 2008, when my oldest son was looking at going to college, I came back to NIF and I started in NIF as an ILS operator, so injection laser system. Then I moved on to lead operator for the NIF in general. And then I became essentially the work center supervisor in 2015.
Wow.
So, and then here we are today.
That's very impressive. So at your time at the National Ignition Facility, what do you like the most?
Oh, that's hard. Only because, and I don't know if people get tired of hearing this, but it's just a wonderful group of people. I mean, we ourselves, as Kirsten knows, and I hope she agrees, we have a great group in alignment operations. Our managers that I work with and work for are supportive and just always willing to listen and help out. So I know I don't feel segregated or separated, even though I have been working at home for quite a while because of the pandemic. And you know, we try to keep it a pretty close group so that all of the operators and the technicians feel open to, you know, come to me, come to Rob and voice their, whether it be opinions or concerns or, hey, we can do this better. Let's make a change to this procedure, that kind of thing. So that in itself is wonderful. I think just the amount of brain power that you interact with every day. You know, scientists and engineers are around the corner. I have found in these last 4 or 5 years that most of the people we work for, if they're not engineers, they're actually physicists and multiple doctors, and didn't even know, because you deal with them every day. Is just, especially the shot RIs, the shot responsible individuals who actually make, or who have actually not made the shot, but created that shot or that experiment. And they're just such normal people, and maybe is something that I didn't really realize. I think I always thought physicists as, oh, I can't talk to them, they're so smart, oh my gosh, you know. But in our realm and what even Kirsten deals with every day, they're just regular people, you know. They do, yeah, they are smart, that's for darn sure, but they're just, you know, like everybody else. And I think that's just what I enjoy, is that whenever you have a question, there are so many resources and people that you can ask. And with NIF being a 24/7 operation, you can ask that at any hour of the day or night. Mm-hmm. So if you're working owl shift and you have a question, you know, about, well, why did this fail on the shot, or what's happening here? You know, we have shot RIs and system expert, SME, system, why am I not thinking of the word? System manager expert, sorry, that are on call, and we can call 24/7 and ask those questions. So it's just nice to know that you have, you know, backup and people always there to help out and answer questions.
Now you yourself are an SME, right? A system manager expert for the Atlas system.
The Atlas system, right.
Yeah, I just wanted to add that in there.
Yeah, so the Atlas system is very interesting, and I know I'm probably taking up too much time, but it is a laser tracker that we use to automatically align diagnostics and targets inside the target chamber. So it has helped out tremendously in just alignment in general, which is much more automated. So it takes less time. It takes a little bit of the pressure off of our target area coordinators and our beam control target area technicians. I mean, it has its own issues and it fails in its different way, but it does make the whole system a lot more automated, which has helped the bottom line of getting more shots done per year.
Thank you.
Okay, yeah. Lisa, you mentioned a little earlier about all the different applications of like what you do in photonics technologies. And, you know, some of the things that the National Ignition Facility does, you know, like nuclear non-proliferation and cancer treatment. Like, how do you feel like you help make the world a better place, like, or at the National Ignition Facility?
Well, that's kind of hard. And I only say that because indirectly we are responsible for getting those experiments and, you know, getting the data for, as you know, cancer research and nuclear deterrent and what is the word you use? I can't, as I start rambling, I can't. Yeah, thank you.
Okay.
You know, and so there's just a lot of interesting I shouldn't say technology, but just physics that we work on for every shot. And so as Kirsten was saying, you know, there was a high yield or a CAT-C, which is how they categorize it, a high yield shot today, whereas tomorrow may just be laser beams to the target chamber looking at energies off of crystals. I mean, so we run the gamut of, you know, from doing, you know, nuclear deterrent to just, hey, what happens when we do this with a pulse shape? I mean, so it runs the gamut. And it's also something that as lead operator years ago, and Kirsten can attest to also, is that each shot, no matter what the end goal is, whether it is for creating ignition or just getting energies off of crystals, is just as important as the other shot. So for us, we run the same checklist, we do the same process day in, day out, because our main goal is to provide data. And that data then drives you know, all of the scientists and engineers to then make all of these breakthroughs in, you know, whatever that niche is of what they're getting the data from. And and I shouldn't say most of the time, but NIF is the only place they can get these numbers and this data and that information. So, you know, we're that one place in the world that can get that for them.
Wow. That's so great. Like that your education like offered you all that opportunity to make such an impact. And one thing about, you know, schooling that I wanted to mention, I don't know if you're aware, but all three of us have something in common where we were all one of only 2 women in our class. And, you know, it's amazing, you know, to be like with both of you here today, but it really kind of makes a statement, I think, about the STEM gap and how like not a lot has changed, and kind of like the importance of like what we're doing here today, you know, like offering mentorship and networking to other women who are trying to make it in this field. So like, I wanted to ask, like, how, as like being a woman in a male dominated workforce, how has that impacted you, and how did you like deal with some of those challenges?
Well, I've had that question many times, and I feel like I'm very, very fortunate. When I was in tech school, as you mentioned, there was me and another gal that graduated. We started with 3 girls, but again, this is early 80s, and one of the gals ended up getting married and having a baby, so she stopped school and became a mom. That's just what we all did, or what you did then. The other gal graduated. I don't recall where she went to, but I guess I don't remember having any issues in tech school, you know, with being the only girl or one of the two girls there. So, our instructors were great. And then when I got hired, my first job out of tech school was at Lawrence Livermore Lab. And so, yeah, I mean, that was a huge step. So it was also very inviting. And the lab being, was run by UC at the time, University of California, was more of a campus type atmosphere. It was more of a educational arena. So I didn't feel that male domination too much. Occasionally it would rear its ugly head. And even to this day it does. There's sometimes, you got them old school men out there, and you just kind of, I don't know, for me, I let them go only to a certain point, and then, it's like you have to kind of stop them and just show them that you know what you're talking about. Because a lot of times they'll just think, oh, you're just a girl, you're just a woman, you don't know what you're talking about. So, that's still there. I think that will always be there to some point. But it's just a matter of, having confidence in yourself and confidence in what you know, and communicating that in, a tactful way, because you can't act like a man sometimes, or most of the time, right? Because it's not looked upon the same way. But I don't know how else to answer that, is that I have not seen or been a part of too much of, the male world versus the female. And most of that has just been working at the lab, because it's I think a very inclusive environment. And there's resources. If you do have an issue with someone, if there is, whether it be a man or a female, right? It doesn't really matter the gender at that point. There's people you can go to, and there's the ombuds program. There's, supervisors and other mentors and the lab has had a mentor program, since I can remember. So there's always been an availability to have some of those issues. You can get help with it. So
would you say it's gotten better?
I think it's gotten better because it's been talked about more. There's much more awareness, just in our lives in general, but the mentor program is definitely being spoken about more. You can find it much easier than you used to. I think before you would have to go dig into the engineering website, and it'd be way down in some little corner of a screen kind of thing. So now it's just much more visible. We have posters all over for they call the ombuds, which are just technicians and people like the rest of us, but yet they're there to listen to you, right? So it's a good place to vent and to say things and know that it's going to stay just with that person, but you're not talking to your manager or your supervisor or somebody that then needs to take action. This is a place where you can go and just kind of get it off your chest and ask for advice. What do I do with this? Should I go to my manager for this? Should I go to the supervisor? Should I maybe go to my manager's manager? So it's a place where it's a safe place where you can ask those questions again, which we always had, but now it's much more visible and much more easy to access.
Well, that's so reassuring to hear that those are in place. And I think that is largely in part thanks to people like you who really kind of are pioneering in the field. So thank you. And I guess so I could just say, what is some advice you would give to women who are either studying or thinking about a career in photonics?
Yeah, I think, and whether it's, studying photonics or being in photonics, I think just in general is to be confident, but not arrogant. Be confident in what you know, be steadfast in the fact that you do know what you're talking about. Try to, which is something I never got. It took me a lot of years to figure this out, but to learn how to speak to different people, right? Whether it be a man or a woman, I've always been very forward. And so I just kind of put out the facts. Well, it took me a while, probably the first 10, 15 years of my career to realize not everyone accepts that the right way. They don't accept it the way I intended it to. Mm-hmm. And so then you've put a barrier between you and whoever that person is. So it's taken me a while to realize those soft skills is what I've been told they're called, right? So, I would have a conversation, say with Kirsten, and we would have this discussion. Well, then I would turn around and, John, who's in the same group and doing the same job, I would address it differently just because of how he receives information or how he wants to receive the information. So that's the part that I had to learn, and it took me a while to learn because that was never taught in school. School was strictly, the ones and zeros, right? It was all binary. It was all facts. It was all, well, you do this or this. There was nothing in between. And so I don't know what curriculum is now, but I'm hoping there's an emphasis or a little bit more of an emphasis on, on something like that. Or maybe it would be a class that, not just women can benefit from, but everybody, so.
Yeah. Oh, that's great advice.
Yeah. Other than that, it's you just have to understand, what you know. For the longest time as well, when I first started, it was a different generation, but it was like, well, men are always smarter, so they're going to know more than you no matter what. And, you have to break through that, right? And mentally yourself realize, well, not always, right? And so have the confidence to be able to, I'm going to say call them out, but not really call them out. Just, make your point clear that, it's, that may not be correct in a tactful way.
That definitely takes some depth to navigate.
Yes.
Seems like you've learned that very well.
Oh, thank you.
So in your experience, what is something unexpected about photonics that you learned only after working?
Well, I think, and this goes back to when I first started working in Avalos, is just the day-to-day different work we would do. We'd start in the morning and we would align our laser. We only had one laser at the time. And then, a few hours into it, it's like, oh, well, this interlock isn't working on an enclosure. So you would fix that interlock. So now you're into the, low voltage electronics. And then, well, then you have to test that interlock. So then now you're going to go to the rack or the crate and verify that all the bits and the signals work. And then you go back to doing what you were tasked with in the morning. And then you find that a piece of hardware broken, like a mirror mount is now jammed. So you'd have to take that off the wall. And at the time, this is again, back in the late 80s, we had access to a machine shop. So they would let us in the machine shop and we would take care of whatever was bound up on that mirror. And then you put it back in the system and away you go. So it was just a lot of that difference of tasks that you could be doing in a shift all day long. It's like, well, this is what you plan on doing. This is where you start, but it's deviated from that. And that was something I didn't expect, because going through school, it's like a lot of it was geared towards being, like a laser, oh gosh, I can't think of the words, where you would go repair lasers at offsite. There are different places, right? You would go to a doctor's office or where it was, field service. Thank you. So then, you go to field service. So you're working on this laser and you start in the morning and you fix the laser and then you're done. Well, in photonics at the lab is just the amount of diversity in the work only because of the size of these projects. These huge lasers, which are just found no place else in the world. So you are doing one-off all the time. The work that Kirsten does every day and the interfaces she works with every day were developed at the lab, and the only place they're used are at the lab. So it's also hard to realize that we're the only place doing that because you do it day in, day out.
That's right. Thank you for your answer. We're reaching the end here.
Okay.
To tie us over, could you maybe tell us a light joke?
Well, I had to look one up because, and they all tended to be the same, but I did find one, which I probably won't be able to find now, but, why did the scientist eat photons after lunch?
Why?
Because he wanted a light snack.
Oh, that's a good one.
That's almost like a dad joke, right?
Yeah.
I love it.
Well, thank you for your time, Lisa, and sharing your experience starting as a technician in your career journey to where you're at now.
Thank you, Lisa.
Yeah.
Thank you. You're welcome.
All right. Thank you. Until next time, let's keep it light.